recording. Cool.
Uh,
Oh, there was something wrong, right? I remember that. There was
was
something
there?
fundamentally fucked up. Because we were not collecting. Ah, I remember. We had to go to the preprocessor and fix things up. Have we done doing that? Are we done?
I think so. Let me just double check.
I remember. It's because we were not doing the collection of things inside modules, the directives themselves. And it took a while for us to figure that out.
Yeah, it um, compilers are subtle beasts.
But then I also think it was they just forgot. Like, if you think about it, that's kind of obvious that why we haven't done that. That sounds stupid.
Well, the Guardian Knot is a thing for a reason.
Yeah, yeah. Okay, but if this is all right, what happens when you run the code? I remember we were printing some stuff.
Right, we were. So let's see. Dune, Ezek, Karuta. This can go away actually. Compile, examples, modules.
Oh, I also had an idea. Broken. Oh,
Um,
line 5. Oh, thanks, compiler. Here's the
oh
thing,
yeah,
Annie.
no, this is deliberate.
Uh, we could. Here's my pitch. You don't have to say yes for it. We could use the less hours we may work during Carnaval and implement the parser during that holiday.
We could implement a parser during the holiday.
Because people at work will be, well, the, the people we work with will be out, right? We
That is
may
true.
not be out, but we may have less hours because there's less things to do and less things to be done. And I think it's an entire week. I think we can pull it off the entire parsing in a week for sure.
I'll have to see if I will actually have the time because I have other things to do besides, the client.
No, okay then.
Um,
Cool.
I hope that we can though, because it would be nice,
Yeah,
and
because
it
you
would also
love
be nice
parsing, right?
to. Yeah, I like parsers. Um,
Yeah, so that's what
parsers
I
are
thought.
fun.
That's what I thought. Okay, anyway,
Okay, so
so remove the broken thing and let's run this again.
right, so this is deliberately broken. So, oh yeah, and comment line doesn't work here. That's fine.
You cannot have multiple definitions when declaring a predicate in a signature. Second definition here plus two other definitions. Yeah, this is so good. This is so freaking good. And it works.
Very nice. Very, very nice. Okay,
Are we done with
so
predicates then? Predicates inside a signature, I should say.
predicates inside a signature. I think so. We just need to. I wonder if there's an easy way to do this. I want to be able. I want to check actually. Um, you know what makes me really sad?
Tell me about it.
When you have a data structure, but they don't have a standard or a default way to print it.
Well,
Like I'm
that,
really spoiled on that because Lisps obviously have a textual representation for everything, right?
no, I'm
Well,
also
most things.
spoiled by that because of deriving type classes.
And even on low-level languages, I'm also spoiled because Zig actually defines a lot of nice print representations by default. Um,
Yeah, that's actually awesome. The fact that they're exploiting the reflection, the compile time reflection to probably do that, that's awesome.
yeah, no, they are. But then we go to OCaml, which is a very nice language in general, and you can't just print a map.
Well, but that's because they don't have, like, you cannot just have a raw map like you have in enclosure, for example.
Okay,
That
but
sucks.
we are using batteries, which is supposed to be, batteries
No, but there
included.
are
That's
there
the whole.
is a print function in batteries. We just don't know how to use it because it uses features of the language that I particularly am not familiar with. So I don't know how to use it. But it isn't there.
Okay. Oh, it is there. Okay. Well, in that case, we need to figure that out because I want to print maps, honestly.
Well, we need to figure
Um,
out what the magical stuff that I have no idea what it is.
okay, so compile signature. Actually, we should compile clause. This thing outputs a list of forms, right? Eventually.
Yeah, but that's the main umbrella function. We need to go into the details. So where is the compile directive? Yeah, 278 for sure. Then there is probably a to do or a print in a pattern matching somewhere. After we identified that
Directive.
after we identified we are in a signature, we are probably calling a function to handle the signature, which we are, 251. And then in there we are probably skipping everything that is not um, everything that is not a predicate. Yeah, line 214.
Yeah, actually, what I would like to do, ideally, is something slightly different. I would like to be able to just signature, blah blah blah. We call compile signature here, right?
Yeah.
I would like actually to do something like this. Let new compiler equals in. Then we obviously want to return the new compiler to maintain the behavior, but I would like to be able to just like print um, print dict or whatever, print map. Uh, this is not real, of course, but I would like to be able to do something like grab the I forget. We have an
The
environment, right? So we would have to take the compiler dot inv dot what's the type of this? It's a module of comp times to multi-declaration. And that is, yeah, we will have to go to the modules and basically look up the signature and try to print
yeah.
it. That's what I would like to do.
Well, you can derive the ppx of show on our type, and then you can try to use the magical print function from batteries. But you have to derive the printing for our stuff. So you have to put a bunch of derivings on the types on the top. And then I
Okay, let's.
imagine this is composable with the magical print function, and then we are done.
Um,
That's actually a pretty good question. How are we planning on supporting this type of thing? Well, we don't know the effect system yet, so maybe this is a dumb question.
Even without an effect system, this is valid because you may want to stringify something, right?
Hmm.
And ideally, the stringifying and printing should be consistent with each other, right?
Well, but then let's ask the question: which type of strategy are we gonna? Well, but we have kind of like the same Lisp properties in this regard, the homoiconicity. So it shouldn't be a problem for us to print things for the user.
Unbound value set pp. All right, because this is an external module and it probably doesn't have.
What's the problem?
This doesn't derive show apparently.
Oh, that sucks.
It would have been so nice, but it isn't.
That sucks, man.
Well, in that case,
Well, if we cannot fix that on our right now, I don't think we're gonna be able to pull it off the easy way. We're gonna have to do the printing ourselves.
uh, let's.
It sucks.
Yeah, that kind of sucks.
But we don't really need it, right? You just want to print it to have like a
Yeah, I
make
just
your
want to
mind on
see.
peace, right?
Yeah, I just want to see the thing in a data structure. that we're constructing.
Yeah. I would rather go into the after effort of making that when we need it. Right now it's just a good to have, not a must to have. So I would just continue because I believe that we are doing the right things.
Okay, let's see. We need to deal with. I'm pretty sure we have a bunch of to-dos here,
No,
right?
no, no, it's 214 for sure. So
The preparato.
we need to implement the understanding of modules and other signatures inside the context of a signature. That's what we're gonna do.
Right, because signatures handles that differently. Okay, so compile signature.
Yeah, so I believe there is a catch-all in the pattern matching, and then we just need to deal with that.
Um, compiled signature. We have a happy case. Multi-declaration.
Yeah, now we need to do the pattern matchings of the other things now.
All right,
Man,
so
it would be really useful to have some sort of like the pattern feature that Haskell also has. Because this is going to be really annoying. You're going to have to go to the directive, check for the name, check if the name is module, and then things like that. That's annoying.
this is. Oh, right, we actually have to parse the thing. That is
Yeah, yeah.
that is true. That is very
So,
true. Okay.
um, how to define Haskell in OCaml? Is there a thing? Can they define a pattern?
Okay, so if we have a directive, it's going to have a head
Yeah, you need to extract that, check if the name of the func is module. Man, it's pretty fucked up. Like, pretty annoying.
and a list of clauses. Actually, the body of a module must be empty, right? In a signature.
Yes, actually. Uh, defining a pattern
But the
in.
body of another signature may, yeah, okay.
No, 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 but that is easy. We just need to recursively call ourselves.
Okay, so if it's, um, actually, let me open another window here.
Ah, here it is. Pattern synonyms. That's what I'm looking for. Is that a thing in OCaml? Synonym OCaml. Ah, okay. They don't have it.
Okay, so it needs to be a functor. It needs to be a functor.
Man, that's pretty sad, you know? That's actually pretty sad.
Okay,
And somebody asked this two
so,
years ago. This is pretty recent.
okay, if the name is, um,
Do you
let's
know
start
what
with
is a pattern
modules.
synonym, Mario?
Not really.
It's the ability for you to declare, like, essentially a type. Actually, I'm not going to try to explain this. This is going to take you 45 seconds to understand. Just open this link here. I sent it in the chat. I think this is pretty useful to know about. Of course,
If
you
anyone
were reading
knows,
color
if
forth.
yeah, if anyone knows, this is actually a thing that Chuck Moore wrote in the 70s, apparently.
Yeah, of course you were reading that.
Let's go to Nekoma.
So what is the purpose of this thing? Is to essentially not have to write annoying patterns in pattern matching. You can actually make aliases for patterns. So you see the app there, and then you have
Yeah.
the collect args, the annoying freaking pattern matching, and then the proposal is for you to actually have a helper like an alias that you can use that instead in the pattern matching, and then the compiler does the replacement for you. Yeah, you see the pattern there in the pattern in
Uh,
my block there.
yeah, I see.
That would save our lives right now because we don't have, then we can essentially put the underlying abstraction such, oh, you actually have to go into the head of the functor to see if the name is module. All of that we will be able to shove it under the pattern. See?
Yeah.
Okay. Yeah, but just for you to know, because I think this is useful. I never use it personally, but sometimes when you have nested data structures and nested records, I believe this starts to get pretty handy. But I
Um,
guess you need the helper, the help of the compiler. But why can't they just make a PPX for that? Like this sounds like something the PPX could do.
well, then you have two problems. Okay, so yeah, this is a list. Okay, so a module must be empty. Actually, let's handle the other case first, where um, where we have a body, but we shouldn't, because this is just an error check, right?
Yeah, exactly.
This can go away. Declaring a module in a signature. Hmm.
Now we need to make a function that handles each module specifically, I believe.
No, actually, we need to make. Wait, what do you mean each module?
Because you may have multiple modules being declared inside the signature, right?
Well, that just means we need to add the bindings for all of them.
Exactly. So we need to remember them in the environment, and that's it. We're already kind of doing that on line 183, but that's purposely tailored for predicates. We should make a version of that function for modules as well.
Uh, Step, yeah. Start predicate happy case. Um, let's call this module happy case. And in the head is a module. Do we have a module name? We do.
Yeah, no,
We
no,
don't.
I don't think we do. We need to check it out. What is the content that we are about to receive from the directive pattern matching, and pass it in here. Um, and there's also the problem of we have to convert stuff. We have to translate, right? Because we are not handling the source code, the data structure representation anymore. We actually need to translate that into this representation because this is
Yeah.
more useful for the compiler. In the case of the predicate, it was easy because it was just a string. In the case of a module, probably it's more
It's
stuff.
no. For a signature, for a module in a signature level, it's literally just a name and a reference to another signature.
Wait, a reference to another signature. What is that about?
Because if you're declaring that a signature to be satisfied must include, like a module to satisfy a signature must include a module with a given name, you must specify the signature of that module as well, right?
Well, not necessarily, because if you have a
Okay,
module,
this is just a string.
yeah, but that's what you said. I don't think it's necessarily true
We're in the
because
body of a signature, Lemos.
yeah, we are in a body of a signature. You are specifying a module inside the body of a signature. Do you have to specify the signature of the inner module? No, we can derive that for
With
you.
mm, but a signature doesn't have an implementation, Lemos. If you don't say, okay, this module must match this signature, how do you know what that module is supposed to provide?
Well, if the person doesn't specify the signature of, we're talking about the module inside the signature, right?
We're talking about a declaration of a module inside a signature.
Yeah. So if you have a module being declared inside a signature and you do not specify the signature of that module, we should derive that one for you. As
No, we should error out actually.
I don't understand why. Why,
Uh,
if I'm not specifying the signature, I'm exporting everything from the
No, no,
module.
no, 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 no. A signature tells you which guarantees the module that must provide in order to satisfy it, right?
Yeah,
If you say a module must include another module inside of it, but you don't say what that module has to be, what are you guaranteeing, Lemus?
I don't think I'm following the question. Could you go to the example?
We can go to the example.
Yeah, so what I am talking about is about module B here, right?
Yeah.
You can do what we are doing, which is, well, you have a module called B, and the signature of that module is going to be SIGB. That's cool. That's fine. But my understanding, and maybe I am misunderstanding, is that ML allows you to actually tell the signature of a module that there needs to be another module there, but you can just not specify the signature of that one. Isn't that a thing?
Um, that would make the module abstract. Is that helpful in any way?
Well, we're these type of things serve the purpose of encapsulation, right? Would you agree with that?
Well, yes.
If you don't specify the signature of the module being defined in a signature, my
Lemus,
understanding, yeah, yes,
Lemus. A
yes,
signature specifies the interface of the module. If you say, okay, uh, to satisfy this interface, you must provide a module that has no interface.
no,
How
no,
does
no,
that
no,
make sense?
but that's not the correct understanding of that sentence. The correct my understanding of that, which I believe should be the one that we use, is if you don't specify the interface of the module B, there must be a module called B, but it can have any interface and everything will be exported.
Actually, that's not how signatures work, Lemus.
Okay, so if you make a signature in ML and you specify in that signature a module and you do not do the MLI for that module, that's not gonna work.
Like you can say, okay, I'm specifying a module. Here's the implementation of the module. I'm not giving it a signature. The compiler can look at the implementation and say, okay, I'm going to infer the signature for you. That's possible because, well, you have the implementation right there, right?
Yeah, sure.
You would need to do the inference anyways in order to check if it actually satisfies a given signature if you provide one.
Sure.
Um, if you're specifying a signature, you're saying, okay, I need to provide these types, values, modules, whatever, in order to satisfy a signature. If you say, okay, I must provide a type T, but I'm not telling you what the type is, you're saying, yeah, that's an abstract type. The only way to manipulate it is with other things in the same signature, right? If you say that the signature to be satisfied must include a nested module, but you don't give a signature for that, then actually you can try that out right here to see how that goes. If I say, I don't know, actually let's go to the AST because there's a,
Yeah. So if you put a
yeah,
module here in a module
module
type,
type test equals sig end, and then we do, I don't know,
module
module, let's just call
test,
it nested,
sure.
nested.
Sure. Syntax error. How do you do that? EML. Okay, so module inside module type OCaml. Let me see the syntax. Oh, it needs to be capital letter. Okay, so
Okay.
according to the example is expecting a signature of in
Yeah,
the
so you
AI.
yeah, so you must give a signature, see? Syntax error, expecting a colon.
That's actually pretty interesting. You can do that with a type. You can make the type opaque in the signature, but you cannot do the same with a module.
Well, the module will be opaque if you give a signature for it, because it will be you will be ascribing whatever that is to the matching signature, right, associated with the name.
No, yeah, but it's less opaque than a type. Would you agree?
No, it is
You're telling me
equally.
nothing about the type, and about the module, you are at least telling me its signature. Okay, let's be pedantic. You are telling me the name of the type, but that's it. And in the module, you're telling me the name of it and the signature associated with it.
Um, yes, and like you don't have. Here's the problem: you don't have a module body because this is a signature, so you can't infer a signature for the declaration.
I agree with
And
that, and
you
I
must
understand.
provide and you must provide a signature because you need to say, okay, here's how this module can. Here are the valid ways to use this module, right? For a type, that is actually implied by the accompanying definitions, right? You can say, okay, there's a type T, but there's a function that takes that T, you see?
No, that's fine, but what I am surprised is that I thought that if you did module nested and not specified a signature, test would require you to provide a module called nested, and that would be it. Everything else would be free.
Okay, but what should be in that module?
Anything, just named nested. That's what I thought it would happen to be the same principle of the type T, because the type T can be a record, can be an ADT, could be an alias, it doesn't matter.
Um, let me try to go at it another way. If you say, okay, the signature has a nested module, and I don't give you a signature for that module, what can you do with that module?
Because you can't do anything with nested then. No, 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 you can only require its existence. That's it. You cannot do
No, no,
anything else with it.
no, 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 no. Yeah, you require that it exists, but it's completely useless, right?
No, well, the
Because you
requirement
can't.
of existing is not necessarily useless, but I agree. That's it. That's the only thing you could do. Like Tevu is right. Which is he's saying what you're saying, Marinho. That would be useless because you can do anything with nested because you don't know anything about it. And I agree. I just disagree that it's not useless because you are requiring to be there, right? So
But it's
that's not
but it's
necessary.
size. Yeah, but if you do that, it's a module that's isomorphic to unit, effectively.
Isomorphic to unit. I it is isomorphic because I see the map in both ways. But I don't know. Maybe you need this for some more advanced type stuff that I'm not aware. That would be I don't know in OCaml. But I guess you guys are right. Just requiring the existence doesn't give you any leverage because okay, this must be there. What else? What can you do with it? Nothing because you know nothing about it, right?
Yeah.
But you could make functions that receive the module. But
But here's the thing: modules are not necessarily first class. That's the problem.
well, sure, sure, no, yeah, sure. Well, but we are using them as first class for the logger, so I don't know about that.
We aren't actually.
No, we are. We actually are making the modules. That mess is on the bottom of this file. Yeah. So we are actually using them as first class. That is part of the reason it's kind of cursed because it needs to do this boilerplate on the bottom here. And then as you can see on line 189, we are actually using the module as a value.
Oh, so they are first class in OCaml. Yeah, the problem is that they are not necessarily first class in MLs in general, is the problem.
Yeah. Yeah, but hopefully we don't have to interact with any of this mess, and we can just keep the API and that's it. Yeah, anyway, let's continue. Let's close this tangent. I am convinced that even if you could require the existence of a module named nested, if you cannot make functions on top of it, you can do much with it. So it's practically useless.
Uh, okay, so since we established that, we should actually
Check for
probably.
that.
Yeah, we
We
should.
must check for that actually. This
Um,
should be tested before this one though, because you should test if it's the length of the elements of the functor. You should test if it is at least true, because if it's not, then we should error out. Exactly true actually, because if it's 1, we should say that you are missing the signature.
arity equals 2. And
And if it's more than
actually,
1, or
actually, you can destructure this here as well, right?
yeah, elements.
Elements equals, and then module name and
That's not how that works, I believe.
signature. It isn't. It's actually this,
Yeah, but what about
and
the...
we don't need this anymore.
Okay. Yeah, but let's make the error messages for the in the case that you have arity 1 and arity plus then. Oh, and there's another problem. We also need to figure it out what do you have inside the functor, right? Because you may have put it a variable, and that's wrong. It must be an atom.
We can do the checking here, probably.
Sure.
Um, okay, we don't care about these actually. If the arity is 2, actually no, if the arity is anything other than 2, in fact, right?
Yeah, but no, but then we should be more helpful. If you should say error messages that are more tied, like tight. So check arity 1 first.
Actually, there's a better way to do this. If we do this, that means we're still checking that there's no body with the module, right?
Yeah.
Which means that it must be the case that the arity is wrong, right?
Um. Yes. Well, actually not. It. We need to be more specific on the successful case. We need to check if the first element if both elements are atoms inside the module functor. Then this one must be. Then this is an error for sure.
Okay, I guess. Um, well, in that case, we should do something like expert dot. Um,
Functor.
this needs to be a functor.
You see, like this is getting like out of hand, man.
Actually, that's not right. That is indeed not right. It's not a. It's not a. Oh no,
I
it is.
I believe we should start making helpers for this type of checks, man. Even though we'd like the inline pattern matching, this is gonna be so nasty because you have to check the functor twice because you need to have atoms in both cases.
Name equals module name. Arity equals 0. Elements equals empty list.
Uh,
And
and then you need to do the second one, which is the signature name. Same thing.
the expected type is expert. Oh, right, because this is actually. Ugh. Yeah, no, this has location in it.
Yeah, you're gonna
We
have
can
to
just do
extract it.
this.
You're gonna have to extract it. Well, there is a way to do view patterns in OCaml that we could use for this, but then it's gonna be even nastier.
Let's just do the checking here. That's better, I think.
Sure.
Uh,
I personally think we should make helpers and use guards, but we can refactor that later.
Module declarations in signatures must have exactly a name in the signature.
Signature name.
Why a signature name?
Because a signature can be the whole directive, right? So there is a slight ambiguity in here.
The thing is, we actually want to be able to have inline signatures as well. And I'm still trying to figure out how to do that with the new syntax. Um,
We haven't thought of that. So okay, so we want to allow you to actually write by hand that. But that here's the thing: the way that we did the new syntax, it was not accounting for that at all, man.
hmm,
We just thought about named signatures. We didn't think about anonymous.
well,
It's gonna be annoying because you probably want a functor there, right? But a functor cannot have a body. Only a directive can. But putting a directive there is pretty wrong, right? It's gonna look ugly as fuck
mm,
because of the column, the arrow from the beginning being in the middle of a functor. So that's not good. It should be a functor that has a body in a way.
hmm,
Actually, it should be just a body, right? Because we don't care about the name of the signature, so we don't need the signature functor at all. We should just have the curly braces inlined in there. But there's no way to do that right now from the parser perspective. Yeah, that's probably gonna be a conversation for another day.
mm, I have an idea, but it will require us to change the grammar and the types and everything else.
I'd rather do that when we have total control of the parser then.
It's a simple change in the grammar. It's just kind of annoying because the idea is okay. Um, what if instead of having a T list here, saying yeah, you need to have curly braces optionally, right? Which is a list of
To me, that's not the problem.
clauses.
The problem is the
No, no,
functor.
no, no. If you allow this to be a list, then we can say, okay, you can either have arity 2, and then there's no body after that, right? Because you're giving the name and the named signature.
Sure.
Or it can be arity 1, and there must be one body, which is a signature actually, not a
Oh,
module
so you have
implementation.
double curly braces in sequence.
Um,
Is that the
Actually, we
proposal?
can reuse the curly braces as is for this particular use case. The problem is then we would not be able to do a inline signature in a standalone in a module that's actually implemented because then we won't be able to use the curly braces for two things. Yeah, that's why changing the grammar would become a requirement in that case.
Well, but then okay, let me see if I understand. What you're proposing is that you have the name of like you have arrow module, then brackets the name of the module. But this is a module with a signature like embedded. It's like anonymous signature. Then you would have curly braces, and the first curly braces is a signature, and then another pair of curly braces after that to have the description of the module implementation, and then a dot. Is that what you're proposing?
Yeah, yeah. Basically, I want to be able to do this instead of having this. I instead do this, and this is a
A signature.
inline signature.
And then what? Comma?
No, actually, this would only have one set of curly braces. But then, for an actual module,
Yeah, I'm thinking about the actual module.
in the actual module, then yeah, we would have to have a curly brace because we'd have the module name, right? Then
Curly
an
brace.
inline signature, and then the actual implementation.
I think the inline signature for module implementation should be optional because in ML they can be derived because you are providing the implementation, right?
Well, yes, but the point is the grammar doesn't allow you to have curly braces and then more curly braces at the moment.
No, yeah, exactly. So my idea was to actually I'm not gonna even say my idea because your idea is better. I think this is cleaner syntax. But yeah, so we would have to completely not fix that. Not parsing the current
Uh,
parser. Yeah, this is not doable. That actually was my idea, Tevo. But that I think is gonna be
eh,
pretty bad because you are that's putting a lot of effort into remembering the original open brackets.
that
You
doesn't
see?
work, Tevo, because curly braces are not expressions.
Well, but we could make them. We have control over the parsing of that.
Well, we could, but then we would have to say, okay, do we allow code fragments as values in programs? Are we going to do a meta programming in Karuta now? Relational meta programming?
Uh, well, but a relational metaprogram is a relational program that runs before the runtime. Anyway, so I think I like Marinho's idea more than what Tevo proposed because Tevo proposed essentially what I was thinking. I think the syntax is worse because there's too many things closing at the end. The signature may be huge. I rather have a a double body, double pair of curly braces just for that. The problem is that our grammar doesn't allow you to do that. We'd have to change the grammar and change the AST, and everywhere is gonna break, probably.
Yeah.
But that doesn't sound like a that much breaking because it's just a list of lists. Is that a problem? Really? I think we
Well,
should
everything,
try. I think we should
every,
actually try.
the problem is that it's not just this in clause F, it's also this in the parser clause F.
Yeah, sure. And then the parser dot mly is also gonna break. But after we fix that, I don't think we're gonna have many other errors in the preprocessor and the compiler, man. It's just a matter of doing double maps and double folds and stuff like that.
Hmm,
You may
we can
say
do.
that you'd rather not do this right now, and we can do it, I don't know, next time. But then right now we would have the requirement that you need to name your modules inside the signatures. You need to name the signatures of your modules.
Yeah, let's keep this restriction for now, and then next time we figure out the grammar
Actually,
change.
actually, that's not true. Line
Why?
14 has only one body, right? So we can
Well,
exploit that in this case.
yeah, this would work as is if it's a module declaration in a signature. Yeah,
Which is the one that we're currently implementing.
yeah, this would work as is with the current grammar.
Yeah, so I think we are okay with that, but then when we go to the whole idea of anonymous signatures, then we are fucked.
Well, anonymous signatures in concrete modules, right?
Yeah. Or derived signatures out of module implementations.
Derived signatures. But for a derived signature, you just don't give a signature.
No, yeah, sure, but then we have to implement the deriving, right? I also classify that as an instance of anonymous.
Um, that's not actually a problem because this doesn't need to exist as source code, which means the grammar doesn't matter.
Yeah, no. That's the deriving one. The derived one is fine. It's just like the inlined ones that were fucked.
Yeah. Okay,
Cool.
let's make this work because we can make this work without changing the grammar. And then when we go to modules, we can figure out the grammar change.
Yeah. I rather actually implement directive system, and then we put things on top, because then we can already create programs with it, even though they will be limited because you have to name the signatures, or you have to make them derived. Um, but I think that's already like people can do things with that. We can create libraries with that. Because remember, why are we doing this right now? Just to justify record for just for the record. Why are we investing so much time in the beginning of the language to have a module system? Because we need it in order to fix the problem of namespacing of the built-in primitives, right?
Yeah, we want to be able to treat the standard library as a proper module, ideally.
Yeah, that's why we are not focusing on making the examples work, and we are focusing on the modules first. Because you have to rewrite the examples using the primitives from the Karuta module, and that will allow us to run the examples. Like that's why it sounds a little bit out of order, but it is in order. Believe me, we need the modules. It's not just because we love them. It's because we need it.
We need it. Do we have a type on the compiler for plain signature, abstract, module signature? But for a module,
Isn't it 41?
I'm trying to see if we have a type, a way to represent reference to a signature. I don't think we do, right? We just use names.
I think we're just using names. Yeah.
Okay. Okay. But actually, this means then that we should make another case here for the arity1 with the module name and an inline signature, which must be, yeah, an inline signature, right?
Yeah. Pretty much. I think
Okay.
this one is the easier one to do right now.
Are we actually going to use the arity here in the error message? We should, right?
Um, yeah, because we need to check if it's a one, arity equals to one, and then you are missing the signature name. Then we need to check if you are greater than true to say that you should only have true. That's it.
Well, we're kind of doing this up here already.
Yeah, but there's also the problem of somebody putting a variable instead of an atom that we are also not checking in any of them.
Oh no, those checks will have to be here, basically.
Yeah. So
Um,
that's
Although
the
you did in fact remind me that in actually there needs to be an underscore now, right?
yeah.
Uh,
Yeah, but we
there
still
needs
need
to
to
be an
check the
underscore.
arity on 234, particularly just to be able to tell people, hey, you just have the module name. You need the module signature, or hey, uh, you have more than two things, and there can only be two things. That's what 234 should check with the arity.
We're kind of checking that already because here we're checking if we have two things and then there must not be an inline signature, right?
Yeah.
And here we're checking there's one thing and then we need to check that this is non-empty actually.
Why did
When
you? Yeah. Why did you put a binding there instead of just checking for the singleton?
Because we still haven't changed the grammar, which means we still haven't changed the AST, which means this is actually the entire signature, not a list of bodies.
Ah, yeah, that's true, actually. I forgot about that. Uh, okay, but then, if you're doing that, do we still need the arity on 234? I believe so, because we can make more helpful error messages if we know if it's a 1 or a 2 plus, right? Because we could say that you should have only 2, always. We can always say that. But I classify this as a wasted opportunity because we can tell you more.
Can we?
Yeah, if there's only one, and that one doesn't match the previous case. Oh, but that's impossible the way that the pattern matching is written. So arity is definitely not 1. It can be true, that's true, because it may not match the 1 in 218. Um, so yeah, this can be true or more. One signature name,
No, no, no. But you can have an inline signature, right?
not on the case that we are currently putting the error, right? This case that we are currently dealing with for the error reporting, we know the arity is not 1. So we know you're not inlining the signature. Agree?
We know the arity is not 1. No, no, no. But if it's arity 2 and there's an inline signature, you're giving me two signatures. Then what do I do with that?
Wait, repeat the question.
Like if you give me arity 2, you give me a named signature,
Yeah.
but you also give me something here where this is not empty, which means there is a body, which means there is an inline signature as well. That means we have two signatures, right?
But we're not allowing you to do that because if the arity is true, you cannot have an inline signature because you're giving us the name,
No, no, no,
right?
but if the arity is 2 and you give me a non-empty signature,
Yeah.
we are actually going to fall through to this case.
Exactly. Exactly. Ah, okay. What you're saying is that this means that you have at least 2 signatures.
Um, well, we could have zero signatures as well, actually.
Yeah. Uh, no, that one is not true because then we would fall on 218. No, wait. Oh, no, you're right. The pattern matching below that is also checking for non-empty on the inline. Yeah, so no, so you're right. You're right. You're right. You're right.
Mm,
That's
yeah, this is kind
confusing
of
as
sad.
fuck, but okay.
This is kind of sad because we can't have an explicitly empty module. We will be able to fix that once we change the grammar, but right now we can't.
Yeah. Okay, cool. So I guess that's pretty much it. So now let's implement the bodies of those things. So the
Okay,
first thing
so
we
first
should
of all,
do, which one you want to
yeah,
do
we're
first?
not doing this. Um, we should probably do. That's a good question.
The first thing we need to do is to check the names, to check if they are actual atoms. If they are not, we should error out.
Well, that is fair. Actually, we should probably make a helper for this, right? Let
Yeah.
me think for a second. We need. Actually, we need a new type here as well. Um, type. Actually, let's make this local to this function because we're not going to use it anywhere else.
Why do you prefer having a separate type?
I want to be able to handle both the inline case and the named case with the same helper because a lot of the checks will be the same.
Wait, which checks are we talking about? I'm just talking about checking if the name of the thing is an atom, man.
Well, yes, that check will need to be the same in both branches here, right?
Not necessarily. Because in the case of arity 1, you don't have to check for that on the module signature because there's none. You have
The
to check
module
the
name
module
needs to
name.
be an atom no matter what, though.
Yeah, I was thinking about using a list.forAll that essentially grabs a list of expressions and checks if all of them are atoms. And then we just pass that, and we can reuse it in both cases.
Um, we're treating atoms. Let me
Actually,
check.
I lied. It cannot be a list.forAll because we need to report if either the module name or the module signature is wrong, and so we have to keep the elements. So it will be a for all that returns either none or some. And if it returns some, it will actually tell you which expression is not an atom, and you can use the location of that to reporting.
Um, I just realized we actually can't have a qualified atom there, can we?
we Oh, because maybe the signature is coming from somewhere else.
Yeah, we made that syntax restricted to just calls.
Hmm. I see what you're saying.
Okay, yeah, for now we can check if they are atoms. We're gonna have to reorganize the AST a little bit, won't we?
Put some to-dos here because we have at least two to-dos to do, right? We have to rearrange the signature, the type. No, put it on the AST file. We have to rearrange the directives to use double lists instead of a single list, and we need to upgrade functors to also potentially be qualified. Yeah, I forgot about that. Man, implementing this thing is is a lot about scoping. We have to think about all those cases. Okay, where is this coming from?
We do, and that's why the Val calculus is awesome. And by the way, Tevo, here's some food for thought for you. For Lemos as well, although he hasn't read the dissertation, I don't think, so you don't know the Val calculus yet, but there seems to be some kind of very deep relation between tagless final style on one hand and the Val calculus notion of environments and evaluation on the other hand.
Mm-hmm. Iter. Ah,
Here. To do. We want to allow multiple bodies for each directive.
yeah, so let's make the helper. I already found the functions we're gonna use.
Uh, okay, so
It's gonna be match, and then we're gonna make a helper function which is check for atoms, and then you pass a list of things to it, and it's gonna return some or none, and that's it. Yeah. So you're gonna use list.findOpt because that's what matters.
functor. We need to say arity equals 0, and we need to say elements equals empty list, and we don't care about the name. Right? All atoms.
Wait. No. Go back. I was not looking. People opened the door. Let me check for a bit, please.
I can put it here.
That's not
We
gonna
already
work.
have we already have an all underscores.
Yeah,
So
yeah, but that's not gonna work in this case because we need to know which element is wrong because we need to grab the location from that to use on the reporting. That's why I wanted to
that's
use the maybe.
okay.
Just replace the list dot for all for by to a list dot find opt.
Find opt.
Yeah, and the return type is gonna be wrong in this case because this is gonna be option of expression dot t. The
Uh,
boolean is still wrong.
no, yes, but that means okay.
Oh,
We're
don't
not gonna
strip the
use this in the.
location. Don't strip the location as well.
No, that's fine. I'm just thinking we're not gonna use this in the pattern match, are we?
No.
That's probably for the best.
No, no, no. We will use this in the pattern matching actually, because this will grab the name of things, and then it will return us the one that is causing the problem, and then you're gonna grab the location for that guy, and then use that on the with the logger to report it as wrong.
Okay, in that case,
No, no. This is completely correct. Don't change it. We need to do the compose and strip the location and do the pattern matching. This is perfect. Only the return type is wrong. It should be ast.expression.t option. Yes. Now you do a match calling this over there on the left, and then if it's a none, this is the happy case, and if it's some, then we just extract the location and we are happy. We log that
mm,
as an error and we're happy.
and we should also call exit one, right?
Yeah.
So actually, what if we do this in here already?
What if we do this in here? Um,
Like we can make this still be all atoms. This is in fact
unit.
unit, but then we do the match here.
Um, I usually don't like putting exits somewhere different than the actual like main pipeline and putting in a helper. But you can try to see if this works. We can try.
If it's none,
This is
then
a
there's no
happy case.
problem. But if there is something,
You need to grab that location and you need to grab their name. So
there is some known atom, then we need to do logger dot actually. Hmm, okay, what if we do
lock
lock
semicolon underscore.
and then semicolon underscore? Actually, no, we care about the value as well, no?
Yeah, I thought about that, but that I think that's gonna be kind of confusing because this can be anything. This could be a functor, this could be a variable. Are we gonna treat each individual case here?
Probably not. Okay then. Um, logger error lock.
And then
This is not gonna
we're
work, is
missing a
it?
message and the exit one. And
Um,
probably the no wait, what is the problem here? This pattern should not be a constructor. This expected type is base. Wait, what?
find opt takes an A2 boolean, takes an A list, returns an A option, which we're doing. Okay. Then if we find none, we return unit.
Mm. Put the none case below the sum. I'm starting to suspect we need semicolon. No, that's not it. Okay. What is wrong with
Hmm,
this? That's kind of weird. What are we doing wrong in this case?
This function application is partial. What do you mean partial?
Ah, we are not putting the list there. This is returning a lambda. Of
Oh, right,
course.
because the one above was in point 3 style. Okay. Um, well, in that case, we should get
Yeah, we need to
the.
give a name to this thing.
Let's call it args. Why not? And then
Now
that
this is probably
means
better to be parentheses instead of at.
there we go.
That also works, genius. Okay, now it's the semicolon problem maybe? Maybe it's not the problem. This expression should not be a unit literal. The expected type is just unit. So how does that work? Did you just type it down unit? Is that how that works? How do you return unit in a function then?
Oh, it's because we need to do this now, actually.
Oh, okay, that actually makes sense. So there you go.
Hmm.
Expected atom. And then if we're good, if we're better, we would say expected atom got tanana, but you don't have the tanana. So
Oh, but we have the squiggles and we have the display here. So,
yeah, it's not as terrible as it could be. But well, we're lazy today. That's fine. That's actually fine.
okay. Okay, so that means if we go back to the left,
We just
we.
need to call this first. Yeah. And if we don't explode during this, it's because we are okay. No. I think it was wrong because this is the last thing in the body. So this is returning unit to the entire expression. We need to put more stuff because we need to return the compiler. Yeah. This
Compiled
expression has type
signature.
T.
Oh, right, because actually we're accumulating things here, right?
Yeah.
So we need to do something with the accumulator, and we
Module
need
happy case,
to
probably.
yeah, module happy case. This is when we have to deal with the predicate name.
No,
We're
no, no.
gonna have to deal. Well,
There's no
it's not a
predicate name.
predicate,
Yeah.
right? This
This
is
is
actually
yeah. This is because we copy pasted.
um, this is actually going to be the comp time name. Then we need to know if it's a module or a string. I guess we can just take a comp time, no?
Yeah, we need to. I think this is the perfect time for us to convert the source code representation to the actual useful representation. We can either do it in the on the caller site or here. What do you prefer?
Uh, we should do it in the caller side because this will be essentially the same actually for both signatures and modules,
Yeah, that's.
but
I
we want to
agree.
have slightly different behavior in both cases before we reach this point actually.
Yeah, so let's create. Let's do the conversion now then. This is our next task.
Actually,
I don't remember. Oh, okay. So that's good. But I also don't remember the type of that anymore.
no, this is a map, this is not a set. So this is going to be a comp time.
There it is.
Yeah, signature to unit. Actually, no, we need to add this to this, right?
Wait. Yeah. Yeah.
Ah, no, we're building up a compiled signature, which means we have a modules here, which is this thing, and it's a map from the
Wait. Man, now I am confused. We have modules on 31, modules on 38, and modules on 41. 41 is definitely the implementation. But what is the difference between 31 and 38?
What is the difference between them? Um, 31 and 38. They are module signature off. Signature unit.
Like, you see what I'm saying?
Signature unit.
What
Oh,
is the
right. This
purpose
is
of this?
actually okay. Uh, what is the purpose of this?
What we are doing.
This is what we are doing, and we can also have a nested case here. Okay.
Sure.
This is when you have a module declaration inside a signature, which happens to be the case we're treating, but it's also a special case of this.
Yeah, but what is the purpose of 38? What is the case we're gonna use this to as treatment?
Well, if we have a module inside of a signature, we use this.
But that's exactly what we are doing, and we're not using that. We are using 31.
No, no, no. 31 is the accumulator. This is the accumulator. We're inside of a signature, Lemos, which is going to be this at the end. But this is recursive, so it can have this inside of this.
This is recursive. Shit.
Yeah, yeah, it's recursive.
Okay. Okay.
Comp time name, and then definition, I guess. And I'm missing the previous version of modules. So act.modules, and this goes here, right?
I don't remember the order at all.
It's
Yeah,
the string, it's the
yeah,
thing, and then it's
yeah, you can to the
the
end.
okay.
Oh, but this should work already. Why it's fucked up? This expression has type signature betmap.string.t, but an expression is expected to of type comptime betmap.string.t.
Oh,
What?
right, because we're actually, yeah, no, actually, this is not the right thing. This needs to be this.
Yeah. Remove line 203.
Sure, yeah, this needs to be signature, happy case. This can go away.
Yeah, this is the confusion. Yeah, because you are actually calling signature there, but inside of the signature IDT, there is a module.
But that's not,
But
yeah, but this is
we are
not,
using signature as a namespacing. So
yeah, this is not actually a module implementation. This is a module signature, this is a declaration of a module in a signature, which is just a name and a signature, basically.
yeah, yeah. We should really put those types away, man. They should not live in this file. But we can do this after we're done.
Hmm. Okay, so I guess we would have to do
Signature happy
signature happy
case.
case.
Best names, man.
We know for a fact that the module name here will actually be
Um,
an atom,
yes,
but
but
this doesn't have
we
the
need
right
to unwrap
type.
it. Yeah, no, we need to unwrap it. We can do the pattern matching and use unreachable because we know for a fact that if we got here, this is definitely an atom. We
We
need
should probably.
both. Use tuple. No, use tuple. Because we also need to do the same with the module signature. So use the tuple trick. Yeah. So if then you can pattern match the happy case. So
I have this as a
Uh,
functor.
ast.xpr.functor.
I don't think we need that because it should be able to infer from here.
Let's hope so. And then name equals name module name.
Name equals module name, rt0, elements
Ah,
is
but this is
empty.
yeah, but this is doing no. You don't need to do any of that, man, because we already did that on the all atoms. So this is redundant.
That's fair.
You need to be careful though. We are doing shadowing here, and we still need a location out of the ones from above.
Do we?
Yeah, because we are probably saving the location in a new data structure as well. So I believe we need to be very careful about shadowing. And then the catch-all should be unreachable. Simply unreachable. Actually can be unreachable, not simply, because you can put the location of next as well,
The
as a
location
whole.
of next. Okay.
Yeah.
Of next.
Next.lock. And you can do exit one instead of unit there.
And it should say consistency
Okay, that was pretty bad. Let me see if I can go back.
atoms.
I dropped.
You're back.
Um,
If you dropped at all, I'm not
yeah,
sure.
no, I did drop. Yeah, so the line 246 is now fucked up because we have to change the data structures, right? We are still using the functor things. We have to convert to the new type, and we have to not use shadowing.
Wait a second. There's something. Yeah, this is the problem. Okay. And this can go away. Okay, so what's the problem here?
The type is wrong, but that was expected because this is something coming from a functor. So this is source code data structure, and your function expects something else. We have to change the representation, but I do want to remove the shadowing before that because we need to keep the locations, man.
We need to. Why?
I'm pretty sure the new types that we created for the compiler representation of directives, they are still saving the original locations for reporting. Right now, we have the locations on 245 and 246, but then we are shadowing the names of the original things. You see?
Okay, in that case, we should probably. Let's go prime. Prime is a better convention, right?
Yeah, pissing the ML people, pissing them
But
off.
I mean, it's valid syntax. If you don't like it, you shouldn't have it in your grammar.
Okay, now we need to grab whatever this is and convert to a full signature type.
We need to do a lookup, basically. The problem is we need to do a lookup, um, and this is kind of annoying because we actually get into the problem of, okay, now it's important that we have collected the names beforehand for all the declarations, which we actually aren't doing yet. We have started them to the top, but we aren't actually
Going throughout all the files that you asked to compilation and saving the names. Like, that's a completely separate pass, right? I don't think we need to be worried about that.
but we need to actually because if I'm declaring a module with a named signature, I
The
need to do a
signature must
lookup
live
on the
somewhere.
environment right now. and that's
Yeah,
nowhere,
this
right?
mean no, no, no. But this means that the order of declarations and of modules and signatures matters. You need to have declared the signature first, and that's like very common behavior in many programming languages. I don't like it, but people do that. We can just use that for now because to not do that, we have to do what you said, which is to do a pass for scanning. And well, we could also just
Uh,
do the patch up thing, but that sounds annoying.
Batmap
You
dot
know what I mean?
string. Yeah, I know. Yeah, I know.
And then we'd have to save refs, man.
That means this is not quite the happy path yet because we actually need to do another match. Okay, so
It's
find op.
module signature prime. It's definitely module signature prime.
No, yes, but with
So if it's
some
sum, this is nice.
defined signature, we do this.
And then none, we need to report.
In the none case,
We should say an error and a warning, because we should say warning. Um, Something about the order mattering, right, for the user, and then the error should be uh, could not find signature.
yeah, we need to grab the modules, I think, right?
Yeah, but the modules is inside the environment. Do we have a strict access to the environment? I don't believe so. I think it needs the acc.modules. Yeah, acc.modules. This is a folding function, but you need to remember that. All of this is in the fold.
Okay, this is not exhaustive.
That doesn't make any sense, right? Yeah.
There we go.
Let's put the message here on 253. Why not? That's pretty easy. So what do you think? We
Logger.
just error or we also give it a warning?
For now, we should error out because there's nothing we can do if you're trying to use a signature that's
Yeah,
not
but I
defined
think
yet.
I think it's nice to inform the people that the feature will come.
We can add that to the error message regardless.
Sure. So you need to pass a
Uh,
location, which in this case is going to be module signature.lock, yeah? And then that, and then that.
um, undefined signature name. If you think this is defined, but the definition, if you think this
Can I try
should
to be can
be
I try to be more
defined,
fun? Can I try?
sure.
Instead of if you think blah blah blah, you just do remember column. The order matters. That's it. This is on the same
That's
spirit of the foot gun error message. And then the order matters and then parentheses for now. Exactly, exactly. And if it was Mageta, he would put the blink emoji in the for now as well.
okay.
This is awesome. No, no, no. We need to run. We need to run a program to see this happening. Come on, come on, come on, come on, come on, come on.
Okay.
This is
Yeah, this should
perfect
get it
already. Yeah,
actually.
this is already
Yeah.
perfect.
Let me just comment this. Doing build.
Oh,
Oh yeah,
this is
we have exit one to do
yeah.
there.
Oh, okay. Thanks, compiler. 266. We're not using any of those things. That's also true. Man, yeah, comment all of these 262 all the way to 270. Fuck that.
Okay.
We have a catch-all on the bottom. Who cares? Okay, let's
All
go.
right. So
What?
expect that.
What? What?
Hmm.
That's amusing. So whatever, we are doing something fundamentally wrong.
Is the condition wrong? The condition is wrong.
Ah, it's the other way around. No. Ah, it is the other way around. Yeah, no, you're completely right.
There we go.
This is what I mean about fun error reporting. This is what I mean by fun, man. Awesome. I love it.
Magetta will be so happy that we added an emoji to the code base.
Oh, yeah. Like I'm trying to get a. I understand there is like a preconception, like a stereotype kind of thing, that if you are a real language, you need to have very pedantic and technical language in your error messages. But I think that's wrong, man. I think we should have fun. And I say we, I mean the ones using the language. Like everybody agrees that everybody is miserable. The error messages may be tiny detail, but they matter.
They do matter, indeed.
Okay, let's wait a moment. Is this done? 252? Is that a thing? Does that work?
Signature sig B, just for sanity check, is deliberately empty.
Oh,
Um,
undefined something something. Okay, so the saving is wrong. The saving of the signatures is fucked.
yeah, it is not quite right yet, apparently.
Yeah, we need to. We are missing some ads. We are missing some ads. No, 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 no. This is the problem. We are doing the check first and adding later. We need to do the opposite. We add first and check later. Right?
Ah, yes, we kind of do.
Yeah, we are missing an
Actually,
ad. We are missing an ad somewhere, man.
actually, no. We're adding this first, and then when we reach here, this should already be defined,
That's what
right?
I'm saying. I think there's no ad on the line 12 being happening right now. That's what I'm saying.
Ah, okay. Well, let's
We
see.
need to do the pattern matching on the signatures all the way down there. So go all the way down. More down. More. Okay. Yeah. This is the beginning of it. Okay, so compile. Huh. It's definitely line 309. This compile signature should do that for us, but it's not. Wait a moment. No, 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 go back, go back, no, no, go back, go back, go back. There's something wrong in that pattern matching.
Ah, it's because I think because like we're running in a loop to compile the body, right? But are we actually?
Ah, okay, this is the ad. Okay, this is the actual ad, right?
We are. We actually
Yeah,
are,
but go back to the
apparently.
pattern matching. Scroll down a little bit more, just for me to double check a thing. I think, yeah, there, 311. So we are saying that this is a signature, one. That's fine. But we are saying that the elements. Ah, okay. The element. Wait, but the elements is empty. Ah, because this is the body of the functor. Wait, is this pattern matching right, Maninho? Is this right?
Well, yes, we're checking if um,
Oh,
there's
this
only
is the
one
check of the
argument,
name of the signature. Ah, this is the
and
name
that
of the
argument
signature.
is the name of the signature.
Yeah, so okay, so this is correct. What now we need to go to compile signature. Yeah, this is where the problem is, for sure. So existing. Okay, in the beginning it doesn't exist because we are doing line 12. So none. Nice. So continue going. All of these are helper functions, nobody cares. This is still a helping function, nobody cares. Blah blah. Yeah, okay, see here it is. 280. Compile signature. And then we fold using the step. We fold using the step. Sure. Our body is empty, so this shouldn't matter. And then we return the compiler with that. Yeah, what's wrong?
Hmm.
You agree, right? The body is empty in that case.
Yeah, it should be.
Hmm.
Okay, this should blow up, right? Because I'm trying to define the same name twice here, right?
Well,
But it
sure.
doesn't.
Yeah, it's not doing the add, man. It's not doing the add. That's the problem. What I don't understand is how we are not adding. Actually, I do have an idea. Go down there. Go all the way down to the bottom of this function. Yeah, here. On 285, print the name.
On 285 here.
Yeah. Before returning, do a print at end line of the name. Okay, let's run this. Scroll up.
Actually, we shouldn't do this. We should do logger dot simply info, actually.
Yeah, that works. And there's color with that, so that helps. Oh, we're not printing anything at all. So that means that we are blowing up inside the fold. Agree?
Yeah.
But how how in the hell did we go through the signatures?
Let me try something real quick. If I comment this out,
Oh, wait, what? Is this because of the reordering of shit that we do in the preprocessor? It
one
must be, right?
second. Ah, you know what it is? We actually aren't handling nested signatures yet. That's why.
Ah, so it falls through. I see. We should not use simply info, by the way. We should use simply debug because info is actually for the users. Because at some point I would like to report times. There's no simply debug, it's just debug. My bad. I would like to report times for the phases so people can have this information. So like it took X amount of seconds.
Oops. Yeah, we're hitting this case. That's the problem.
Yeah, yeah, yeah.
So
So
yeah,
we are not
we're
treating
seeing
nested signatures. That's the problem. Nice.
that makes complete sense actually.
Isn't this very easy to fix though? Because you just pattern match on the directive, check if the name is signature, and then literally calls yourself.
If the name is signature, yeah, you need to recursively compile the nested signature, but then, hmm,
Like we just
yeah, no,
literally
we
call
can,
ourselves, no?
yeah, no, we can do, yeah, we can do that. Um, okay, if let's copy this to make it easier. If it's a signature,
We don't check for anything else. We just let the recursion take care of the rest. We need to call the function down there. So these are now mutually recursive functions. And you know what's worse is that one is a step on a fold and the other one is a compile directive. Crazy shit. Oh, you're actually gonna call
uh,
yourself. You're not gonna call the compile directive doing the checks for you.
we can't do that actually because actually can we?
Why can't we? I thought that was the plan all the way, like the entire time.
I mean, we're gonna do that for modules. The question is, should we do it for signatures as well?
Why shouldn't we? We already implemented all the checks for signatures in the compile directive.
That,
Why are we not using that?
that's fair enough. Okay, so compile signature.
It should be an and, not damn it. And as I said, it's a mutual recursion between a stepping of a fold function and like the caller of the caller. That's crazy.
Um, okay, okay, but I don't think the types will line up, Lemus.
Why you say that? Let's just try it and see what happens. The compiler will tell us what is wrong.
Mm,
Like this is so freaking hard because we work with Clojure. I also have the habit of trying to have the state machine in my head to know, oh, the type is not gonna match and it's gonna blow up. But I don't have to do that in here. No, it's not clause. It's not clause. It's just a compile directive. Be careful.
that means we do need to do the destructuring then.
Yeah, yeah, exactly. Or you may want, okay, you don't want to do the destructuring and just call ourselves always. That's also an option, but I prefer being a little bit more specific. And now you just pass it. Let's see what happens.
Mm,
What's the problem?
I'm trying to think about the scoping implications of doing this.
The scoping implications. Um,
So compile directive.
does it matter? The state of the compiler is always per module. So the implications end per module. Are the
It,
potential problems?
it matters because what's visible outside of the module should also be visible inside of it, and I don't think we're treating that yet.
But that's all automatically gonna work because if you have things outside of the module, well, you have things outside of the signature, but they are in a module, and you put it before the signature because the order matters. Then what's the problem?
That's not the issue, actually. The issue is if we do, like, I don't know, module, whatever, um, actually, let's call this sig C And let's do this and put those backwards, okay? If I
Yeah,
do module whatever sig b
this will
here,
be
right?
possible. Yeah.
The problem is that we need to take the accumulator up to here. We need to add it to the environment in the recursive call to handle this. Then we need to remove it from the environment, actually.
What?
Actually, do we? Actually, do we?
Ah, no, no, you do. Because if you now, if instead of a module on line 15, you have another signature, it's going to be exposed outside of it when you pop back from the recursion. You see? But that's wrong, right? You should not be allowed to do that. You see what I'm
Yeah, this
saying?
is kinda. Yeah, this is. As I said, compilers are very subtle.
Yeah, so the things that you are defining in line 15, inside the body of that, they will be available from 16 onwards, even though they shouldn't because of the scoping.
Yeah.
So at some point, we need to do like a pop of some an operation that reminds me of a pop. Which actually begs the question: shouldn't we use like a finger tree for the environment then? Because then popping is easy. Because if we continue doing what we're doing, we're gonna have to remember the things that we need to pop and manually extract them out. If you have a stack, we could just keep popping.
Mm, that's an option, I guess.
Yeah, but then the traversal is fucked. Because if you are like 5 levels deep, environment wise, then you have to go through all of them manually. And that's annoying.
It is. It is very annoying.
Scoping. Scoping, my friends.
Scoping is hard. Um, hmm.
Okay, but what your intuition tells you, Marin?
We should be able to use the existing type as is, but I'm not sure if it's worth the bother. And we shouldn't. It wouldn't be easier to just, use a stack.
I think it makes sense to use a stack, man.
But the nested recursion is already using the call stack. Why can't you just use the call stack? Is my point.
What a fourth-brained person. Um, yeah, the traversal is gonna be shit, but I guess we don't really have a choice.
Have a header, have output. Uh,
We need to make a list out of these, or a finger tree, on the environment on line 47. Yeah, man, it's literally a stack. This battery gives us a stack? Let me check.
we don't need batteries. We can just use lists for that if it comes down to it.
No, of course we can use it, but if they have conveniences, I'd rather pick that because it's already an included dependency anyway. And they do. Let me check what are the allegedly the conveniences.
Okay, first question. Is it a mutable stack, Lemos?
That doesn't matter because it's all inside a module, so the API is the same.
But it does matter, actually. The API is different if the stack is
No, no,
mutable
no,
or
no, no,
not.
no, no, no. Remember the book. The book says the computer the quantum techniques and models of computation. They actually do say that you can have the mutability being done inside, and the API can be the same.
No, Lemos. There's a difference between using mutability internally for bookkeeping and your abstraction being mutable.
No, no, I understand that, but I'm saying because I'm praying that the API is immutable, but the implementation is actually mutable to make it fast. Because that's going to be our
But
problem.
But an immutable stack is fast, Lemos. It's just a linked list at the simplest.
No, but the linked list is slow.
It isn't actually because you're always operating at the head.
Not necessarily.
Yes, you are because you're using it as a stack.
No, 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 no. Remember, okay, maybe I didn't make that clear because I used the wrong abstraction as the example. When you are pushing extra environments on top of the current environment, you need to do the traversal on all of them because you may be using something from all the way from the top, which is on the bottom of the stack. You see?
Mm, okay, yeah, that's slower than just using the splatting strategy for nested environments where you're actually just passing the environment and adding things and then removing them later.
It is mutable, the stack. It is actually mutable, my friend.
I mean, why would they provide an immutable stack when you have linked lists by default in OCaml?
Convenience functions for stack manipulation.
But, dude, push is literally just cons and pop is literally just tail.
Yeah,
What
but I
else do you
thought,
need?
well, but I thought, especially in a concatenative programming language, you'd have multiple stacks interacting, and then there would be some helpers there.
No, 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 no. You're talking about. Look, concatenative programming is one thing. Using an explicit stack is another. The point of
Sure.
the point of doing concatenative programming is that the stacks are implicit. Actually, you
No,
don't.
no, no, no. You're not getting my point. I'm not saying that they are the same thing. I'm saying that the abstraction being a stack, and because I learned from Chime that you actually want helpers to interact with multiple stacks, I imagine that the batteries stack module would also do that.
Your intuition is not quite right because in a concatenative language, you typically have a fixed number of stacks. Like you don't treat stacks as first-class data. Well, you could implement a stack as a data type in a concatenative language, but the built-in stacks, like they are not actually first-class things.
Okay, so what you're saying is that it only makes sense to make helpers for multiple stacks if you know them ahead of time and they are fixed.
Yeah, like
Sure. Okay, but anyway, it's a mutable stack. It is a mutable stack.
that's kind of annoying.
Okay, but we have to make a decision. How are we going to model this? Are we going to actually use a stack abstraction? Are we going to use a finger tree and then do the indexing manually? Not the indexing, the top, right? The notion of a top.
Yeah, the deep lookups, right?
Yeah, and then we have the traversals. We have
Mm,
the traversals.
hmm. Let me think for a second. What are we actually doing at the end here?
How did we solve this in the Haskell language that we did? I remember. We called ourselves recursively, but we updated the to make a closure. We appended something to the environment, but when it was being returned, yeah, it was being removed. Yeah, manual. Yeah, I see. I see.
Okay, we update the environment with the name that we are defining. I don't think there's a reason, now that I'm looking at this, why we can't just pass the compiler down there.
I mean, down there where?
Like when we're doing a recursive call to handle a signature, right?
Yeah.
Um, the return value of the recursive call is going to be the compiler. It's going to have this env here with the.
Yeah, but
added
no,
binding for the
so that's
signature.
what you mean. We should not do that. We should actually return the compiler and the updated output separately, because then we can ignore the new compiler with the broken environment notion and
No, no,
use
no,
the
no, no,
previous
no,
one.
no, 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 no. The the environment is actually not going to be broken because we build up the nested thing in an accumulator, right? Using this fold up here.
Sure,
That means since we start with an empty thing here for modules, right?
sure.
That means actually that we're not going to add anything to the environment until the very end when we return.
Yeah, but these are mutually recursive functions. That's the problem. It's
No,
not
no,
a
no,
simple
but this,
recursion.
no, no, no. But the recursive call doesn't have to be a tail call, Lemos, is the point. Actually, it can't be a tail call, in fact.
Oh, but then that's what I said. We're gonna do a let, do the recursive call, and instead of just blindly doing the tail call, we would gonna have to like remove the stuff, right? Somehow.
Mm,
Here's my understanding. At some point, we're gonna return a compiler that has extended environment. But because this is a return of a recursive call, that compiler should not be used anymore because it has an extended environment that will break the scoping. So we need to grab the result of that, ignore the new compiler, and use the previous one. That's why it
if we
cannot be a tail
ignore
call.
if we ignore the new compiler, we won't get the compiled signature that we just called the recursively to obtain.
Mm, yes, but that only matters until we finish the current unit of the current directive, the compilation of that, right? Because for example, on line 15 there, you're defining module whatever. Module whatever only matters for other bindings inside signature C. Agree?
Yeah.
At the moment that we are done with SIG-C, we need to drop that compiler environment because it's polluted with things that should not be visible outside of SIG-C, right?
But that will not actually be added to the environment, in fact.
But the way that the code is currently written, I think it will.
It won't, because the way we do it is we step through the body using a fold left, right?
Yeah.
This step function here is going to build up the accumulator, which is going to become a plain signature at the end. We're not touching the compiler. Well, we're not returning a compiler here at all, actually.
Ah, that's why this is not a problem because we are actually not carrying the updated compiling throughout, right?
Yeah. The problem is that we may actually need to do that. Actually, do we?
No, actually
Let me
we
think.
will, right? Because if you are compiling a signature inside a signature, we want to call ourselves mutually recursive, right? That's what we were discussing. We need to pass a
Hello,
compiler
Nathan.
to that guy. Yeah, we need to pass a compiler to that guy. Which compiler should we use?
The one that we have,
And
actually.
yeah, but then eventually line 291, no, line 293 will happen, and in the mutually recursive call, the compiler will be adjusted, right? Do you agree with me now?
It will only be adjusted when this entire thing returns, actually.
No, 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 you're not getting it. Imagine that you are, imagine that in 6C you are actually creating a SIG-D, okay?
Okay.
What were we about to do? We were doing 276. That, yeah, we are doing 276. And what was my proposal? Just call compile directive with that. Don't do anything. Don't do treatment, zero messages at all. Just do compile directive directly on here. That will end up calling us again. Would you agree?
Yeah.
And that is the problem. Because when that happens, we will reach the line on the bottom there, 293, and then we have a new compiler. And we're not done with
Mm,
6C, right? We're not done. We're still compiling 6C. We just compiled SIG-D doing that. But now the compiler is already fucked.
Okay, I think I know what to do actually. I
Okay,
think I know what to do.
let's see, let's see, let's see.
Okay, so we're actually going to use. Um,
I think the solution is it's not gonna be a tail call.
it's not going to be a tail call. Yes.
Nice.
Compile directive.
And sorry if my explanation was bad because this is very hard to explain.
Compile directive. Does the directive have location? It does, right?
Well, check the arguments, man. Okay. This is probably gonna be next dot lock maybe, and then a func and then some more stuff.
Ah, we're stripping the location, right?
Yeah. So this is
Uh,
next dot lock probably.
okay, so next dot lock.
We need to
Then we
grab
need
the
to pass.
functor out of the directive probably. This functor, yeah.
Okay,
There,
as
there.
directive head, directive
Body.
body, right?
Yeah. Are those it? Is that it? The types? And the compiler. So you need to pass a compiler to it. In.
That's not quite the correct compiler, but I think this needs to have more parentheses, maybe.
You're also missing the in on the let. Just for you to know. Ah, awesome.
Okay.
Okay.
But yeah, this is not but this is not quite the compiler we want to pass here because um, we want the definitions that have been made so far in the signature to be visible here, right?
Yeah, we need those to be visible throughout the compilation of the remaining parts of the signature that we currently are doing. But at the moment that we are done with that, we need to remove those things.
There's an easy way to do that. And in fact, we're not going to get the entire compiler back because, first of all, this is a signature, so it shouldn't, to begin with, compile any actual code, right?
Yeah.
Compiler with env equals um,
Man, this is so.
env with modules equal. And then we do this actually temporarily because we want to we want to have the result so far visible there, right?
Yeah.
Basically.
Yeah. But we don't have the result yet. That's what compile directive is doing. Is calculating the result.
Uh, this is the accumulator, or rather, is it?
Yeah, we have an accumulator
No,
in
this
scope.
is a plain signature with the accumulator.
And this is so mentally hard to think about. Okay, can you explain to me again why we're adding something that we don't even know if it works?
Um,
Compile
what do you mean?
directive. We don't know if it works, right? The compile directive will tell us because it's compiling the internal things right now. But you are already adding it to the environment before we know if it's done. That's what I don't
No, no,
understand.
we know it's not done actually. The
Yeah, but
point is that okay, let me open the thing here. The point is that do you agree that this sig b here should refer to the sig b above?
that's what you're doing.
Yeah.
Okay, no, my bad. You are right, man. I thought you were doing adding the names of the whatever, not the sig b.
Like everything that's being dealt with above this, because we're still dealing with things sequentially at this point, right?
Yeah, the order
That
matters.
implies that everything up here should already be visible here in the body of the sig c.
Yeah. We should make an issue about making the code order independent. I'm gonna try to remember that for later.
Okay, but here's the mildly annoying part. we need to do we need to do we need to do the
Oh, actually. You're not passing the name of the sig B to the environment. You're passing the name of the sig A, right? Because you're compiling sig A, remember?
well,
Si-
yeah, CGA should it be visible there?
because as far as I can tell, sig B is already in the scope because we already compiled sig B, right?
Ah, this is not what the addition we need to make. We need to make something slightly different actually. We need to basically take the accumulator, look at there's a compiled signature, right?
Yeah.
Which
Which is sig
means
A. All of this is sig A.
yeah, we need to grab the modules. Do we grab the predicates? The predicates are not actually.
No, you cannot use them in the descriptions of anything else, so it doesn't matter really.
Yeah, we need to grab the modules basically, and kind of splice those into the
Oh,
environment essentially.
no, yeah, no, yeah, never mind, never mind. Well, can you repeat? I was thinking about something else, but I was wrong. So.
Yeah, we need to take the modules, which
Uh huh.
contains all of the modules and signatures that have been
So
seen so
far,
far.
yeah,
We need to splice them into the env to make them available in here.
yeah, yeah. So I need to grab the modules from the accumulator and do a union with the env of the compiler. Is that what you're saying?
Yeah, we need to do basically a merge, essentially.
Let me check batmap here.
Except
There,
it's just a simple merge because we have to turn all of those signatures here into. We need to wrap them with this basically.
okay, we need to do a map beforehand. That's fine. Okay, so let me check for merge. Man, this was unexpectedly hard. Like, I was not expecting to find this type of complexity. Okay, I found it. There is a merge.
Is there a merge with or something
Um,
equivalent to
yes,
that?
the merge is already a merge with actually.
Does it handle the case like can I wrap a function to the on the value even if there's no
Man,
key collision?
uh, you're gonna pass a lambda that you're literally gonna have access to the key, the value of the first, the value of the second, and return the final value.
Ah, okay. Oh, wait, but that means if the value only exists in one map, that function is not going to be called, right?
It will be called because all of those are options. I just didn't tell you.
Okay. Well, okay. In that case, this is
You don't need to do a map beforehand. You can just literally abuse the lambda.
batmap dot
String
string
merge.
merge.
See?
Okay.
We should not make this in a lambda, man. We should make a helper.
Dude, what we need to do is literally just merge.
No. You need to check for the nuns, right? And you need to do the conversion of wrapping into the signature.
Yeah, we should probably make a separate definition here. Let's just call it merge function, I guess.
So you're gonna receive the key, which is a string in this case, then the value of the
Two
first, the
values.
value of the second.
Oops.
So now it's probably a match. And we don't care about the key actually. So I don't know about you.
We don't care about the key, in fact. Match
Tuple, yeah.
lval, rval with.
It's so freaking sad that the last time I tried to do this trick of pattern matching a tuple in Python, it broke the scope.
I mean, it's Python. What did you expect?
Never gonna forget. And Nathan even doubted me. Like, no, there's no way, man. No, it was true. The scope got fucked.
Do you want to allow shadowing or disallow shadowing?
Well, you know my stance on that. What's yours?
Uh, Technically, we should allow shadowing if we want to be fully general, but from an ergonomic point of view, maybe we shouldn't actually.
Yeah, that's what I thought.
Okay, so some existing none.
Yeah, this is
In
the
that
one
case,
that
we
we need
just
to do the wrapping.
no. The one on the left is the one that already is already there, right?
Oh, you are right. It's the one on the right. Just read line 285. Modules is coming first, so that's what the last
None,
one is.
and then some
Some,
local.
yeah, and then we need to do something about it.
We need to do signature of local.
Local and some. Don't forget the sum. And because they are not functions, don't forget the parentheses.
Because they are not functions, don't forget to print. What do you mean?
You need to return options out of those things.
Do I?
Just read the merge type signature,
Oh, you can decide not to include things. Okay.
which is handy.
Yeah, this
And
is. Yeah, this is. This is annoying.
yeah, and now none should keep it a none, and then some error. Lemos was right. Shadowing is evil. That's the error message.
Uh, well, you just have a different view on design. Is all.
Yeah, but we should explode if we're gonna do what you said. We need to do something. And what are we gonna do about the location of those things? What is the type of these sums? Do we have locations on them? Would be very convenient if we had location on them.
Mm,
And I think
actually,
we
actually, 1 second. We need to. Oh boy, if we're gonna forbid shadowing at this level, then we need to do a bunch of checks in a bunch of other places actually.
what do you mean?
Because we want to be consistent about that, right?
Yeah, sure, but what other places are we quote unquote allowing shadowing for now?
When we are defining the SIG-B here, we're not checking in the surrounding environment if SIG-B is already defined.
We are. There's already a check for that in a lookup somewhere. At least maybe I'm misremembering, but I think we are already checking for that for the redefinitions.
Mm,
Ah, it was the many case, not the signature case. Yeah, so I don't know if we actually are doing that. Well, but if you feel
let's
there's
do the
more
next.
places that we should do that, we can allow shadowing if that's the case. To be consistent at least.
Let's allow it, but put a to do here actually, and let's put this here. Um, to do. Disallow shadowing everywhere, right?
Sure. Okay, but something is still fucked up. What's the problem? This expression has type comp time blah. Ah, we need to add location.
To
I
add
thought they already had
location.
location. That's kind of impressive because one of them doesn't. They don't have it. What is the type of modules again? On the right?
On the right.
Yeah, there's modules on the right of the selected highlighted thing. No, no, not in this buffer. On the left buffer. What is the type of that?
Oh,
Oh, so this has location. What is the type of the other one?
compiled signature.
And what the heck is that?
Uh, is this?
Oh. Oh, okay, so that's the problem. That's the problem. They have different
I
types.
I guess technically we can grab the overall lock. We do have it, right?
Yeah, it's the next
Yeah, we
one.
do. It's this one.
No, no, but there's also the location, the location next. Yeah, this is the wrong function. We need to go to all the way. Yeah, in this pattern matching here, there is the next, and that's what we are usually using as the global. But where do we need
No,
to
no,
put
no,
it?
no. But the next is for the thing that we're compiling
Right now.
right now, basically. Yeah. But this is for things that we already compiled, and we kind of discard a bunch of that because after we check everything and we know everything is correct, we don't need it anymore. But we need some location to plug it in here to make the types match.
Wait, are we dropping locations as we compile things? Is that true?
Why would it not be true?
Because I
After you don't
purposely
know.
asked you to last time to put the location in the new data structures because of that.
No, no, but the point is we.
I think they
Hmm.
do exist, man. Because I remember we put it up there in the new types. As we compile the environment, we are keeping the signature, the locations precisely because of problems like this. And remember, this is not yet even done. This is just a signature. You still have to use the implementation, things like that.
Hmm.
Um, Wait a moment. Go again to the type of the modules for me to see what the heck's going on there. No. Yeah, that. And what the heck is a signature? Is one of those.
Actually, this is not the right one. It's the modules from the environment, right?
Yeah.
It's this.
There's location there. 100% there's location. So is the accumulator the one without location? I think it was, right? I think it is the accumulator that is without location.
Hmm. Do we want to add locations?
To the accumulator in the fold?
Yeah.
Um, Man, I think it is the next. Because what we are doing is... Ah, I see, I see, I see, I see, I see, I see, I see. The accumulator accumulates things without location. Because
Yeah.
it's...
The accumulator is this.
Exactly. So the signature... Oh, but the module T has location. Is that helpful? No, because you can have other things, such as plain signature and abstract. So plain signature is compiled signature, which again doesn't have location. Yeah, this is a mistake. We should actually do have location, but let's just put a to do for now.
Hmm.
We're gonna be obligated to do what you said, using the like top level location, unfortunately.
Hmm. Actually, how much? Okay. First of all, do we build at the moment? We don't,
No,
right?
no, because there we have mismatching maps merging.
Okay. So for now, just to make this type check,
Yeah,
let's
use the top
add.
level. Yeah, add the top level signature to this. That's not gonna work. It's add location. Add lock probably.
Oops.
This is still wrong. What's the problem? This expression has type compiled signature, but an expression is expected. Oh, you probably need to do dot modules. There we go.
Okay, this builds, right?
Yeah, it's being unused there, but it builds.
Okay, it builds. So if we go here and we add location here, how much do we need to fix?
It's not that simple. Because now that I think about it, why predicates are not having location as well? In both cases, 27 and 32.
27 and 32.
Actually, those are heads. Does the head have location? Go all the way up to the file, please. All the way up. Yeah, so we have a predicate definition somewhere. Yeah, we need to discover what the heck is a predicate definition.
No, it's a parameter.
Oh, and we need the predicate map, which is a predicate name. Yeah, go to line 2 and check if the head has location. If it doesn't, then I think we should also add it. It doesn't.
Hmm.
Not here. We should add it in line 27 and 32, maybe. Like, that doesn't... Actually, let's ask the question. Can you require the location of predicates in signatures? Let's ask the question.
Uh, we will need it if we want to ban shadowing because we need to have to point to the place that there's a name collision.
Yeah, but you are against banning shadowing, so I'm also considering keeping it. But then, do we still need the location if that's the case? If we allow shadowing?
If we allow shadowing, we don't need it for predicates because you can only shadow them, right?
Sure.
You do need it for signatures and modules because if there's a signature mismatch, you need to point to the original signature, right?
Yes. Yes. Yes, yes, yes. Yeah, but in the case of modules, though, in the case of modules, I think you do need the location for predicates, right?
In the
Actually,
case of
actually, how does that work in a logic language with shadowing? Because you have the same name of a predicate and the same amount of or the same arity and the same name. Right now, we group them in a multi-declaration. That's not shadowing, you see?
there can be shadowing if you have a module inside of another module and both of them define the same name plus arity combo.
Ah, so it's like within the lexical scope of the inner module, there is shadowing.
Well, yes.
I see. Okay, so in that case, yeah, let's try what you did. Let's try to purposely add location to the signatures and see how many things break. So far, there's only one line there, which is to, yeah, you need to remove the, actually, I don't know which one is wrong in this case. Ah, line 203. The definition doesn't have location. Yeah, but then the collar will break now. 293.
Hmm.
This is easy to fix. Just remove 283. Remove the artificial location. No, you gotta keep this. The problem is on 283 for sure. Now more things are wrong here, so let's read. Modules. So this expression has type contain bet map string t, but it was expecting to have location. So which one of these guys don't have location?
I think it's because this thing needs to have a location, no?
No, but acc.modules already has location now because we changed the definition of the
No, no, no,
accumulator.
no. We need the location to be pulled to the outside, actually.
It's only content, by the way. I'm so confused why we need to do what you're doing right now. It's not
And of
contents, it's
course,
content.
we need parentheses. Wait. Hmm. What the heck is... Okay, let me fix this. Let me actually add this type here. Oh, a this needs to be a
Comp time.
comp time with location um, optional.
Yeah. And then the second one needs to be whatever the accumulator is.
This needs to
Dot
be
modules.
a comp time signature. No, there needs to be a signature.
With location option. Yeah, there's no contents. It's only content. It's in singular. I still don't understand why this is needed at all. We have location on both arguments.
We're pulling it outside, Lemos. That's the point.
We are pulling it outside. That's not comma, it's semicolon. Wait, could you explain to me what you mean by pulling it out?
Okay, so we have the content and the location here, which is the signature that's coming from the accumulator, right?
Yes.
We need to build something with location that has the content inside of it without the location, but wrapped in a signature. The location needs to be outside of that,
We are F mapping this thing. Okay.
basically.
Okay, what else is broken? Go to the compiler. Try to compile.
It compiles.
That's pretty impressive. We changed a core type and nothing breaks. Nothing broke aside from what we just did. That's awesome.
Um, okay, that means we can now grab this nested compiler. And what we need is we need to look up in the modules the name of the thing that we just compiled.
Yeah. And grab it, put it into our compiler, and return it. Agree?
I agree. Um,
You don't need to
I
care about that. All
agree.
the treatment on signatures being done by the compile directive, which is awesome.
But we need the name of this, Lemus.
We need the name of it. Because that's what we need to do the lookup.
Yeah.
Yeah, so just do that. So it's gonna be what? Elements? Yeah, elements, grab the first. That's pretty annoying.
It is pretty annoying.
I think it's time to make a helper for that. So go to the AST module, go to the expression module, and let's make a helper extract name out of a functor. Because this is so annoying. Actually, it should be extract nth name, because maybe you don't want the first, maybe you want the second.
Mm,
You pass an int, which is the index that you actually want, and then you try to do a lookup for you. Or do you want to make a function exclusively for the first?
Well, in this particular case, we can grab the
No, 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 no. You don't want the name. You want the name of the first element. You see?
yes.
Oh, so you're just gonna. Oh, okay. You're gonna assume that it's an atom and then just go from there, right?
It must be, otherwise this would have failed, right?
Yeah.
Um, are we shadowing the name here?
Yeah. We are. Exactly. And that's my problem with shadowing. You need to remember that. Okay, so after the nested compiler, you extract it. Don't
Yeah,
forget to put on
now
the signature of the expression module, the extract functor label.
we don't have to because this doesn't have an explicit signature.
Are you sure? Can you go all the way up?
It doesn't. It's right here.
Oh, but the other modules are not going to use this, so never mind.
Okay, so what we need to do now is we need to do the signature happy case.
Which is a great name.
We need to go to the signature happy case with the signature name here.
No, 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 no. This is not a string yet. This is still a functor, so you need to extract it.
See the expert dot functor label.
Extract functor label. LSP is not. Yeah.
Uh,
Yep.
and then we need to give it
Signature with location and then the compiled signature.
the signature with location and then the compiled signature. The signature with location. Signature with location. That means we need to do the. We actually need to do the lookup here
Yeah,
before
before
that.
doing that, right? So match. Bet map. Actually, extract the functor label first because that's the key for the lookup. So let's do a let before that.
Okay. Let. Um,
Naming naming problems. We can't use name. We can't use signature name. Actually, signature name can be shadow in this case. So we can shadow it if you want. I no, but this one is fine to shadow, Marie.
I know. I just wanna do this.
And you don't need the parentheses. Ah. Yeah, and now we do the match. Match bet
Alright.
map dot string dot find probably find opt dot string dot find and then the signature name.
Actually, this can just be a find because. Actually, no, we shouldn't because that's gonna screw us over.
Definitely, yeah, we definitely shouldn't do that.
Find opt. Signature name.
Nested compiler something
Nested
modules probably
compiler.env
env.
dot modules.
Damn boys.
Yeah, with.
So
If you
if
get a
it's none,
none, that's actually impossible. Otherwise, these would have blown up already.
yeah, or compile directive is not implemented properly. So, but it should be an unreachable for sure.
Logger dot unreachable. Next lock. Exit one.
I think you forgot the pipe on the none. Oh, you cannot do that because sig is a keyword.
Hmm.
Uh, yeah, compiled signature, and then we use that in the signature happy case. Awesome.
Actually, we can do this.
And there's a solid chance that there is location on the find OPT. So maybe that's the problems that we are facing right now.
And we should put this path first, actually.
Yeah, I agree. Yeah, but
Mm,
probably the types are fucked because the find OPT is giving us an option with location information inside. What is the type of modules in the on 305?
one moment.
Yeah, something is very fucked up.
Mm,
That was not enough.
that was not enough. The world is not enough, Lemos.
Of course. I hate when this happens, when we do a pattern matching and like we ask it to like save it and there we are missing a parenthesis somewhere that is completely I found no, I didn't find it. And then we are
Mm,
completely missing a parenthesis somewhere that is really important.
we have a directive which goes up to here, but it shouldn't. It should actually go up to here, I think. Yeah,
Okay. What is the type of modules, please? On 305. Yeah, this has
this is
location.
compatible with location, and this needs to be a signature with location. Wait. Ah, right, because there's a location around the thing.
Exactly. So just do contents and the other thing. Contents equals. Content equal. No, not contents. It's singular.
Content, lock.
Yeah, but
Um,
then the content needs to be more specific, right? Because you are doing the catch-all. What is the problem now?
there we go.
Okay. Um,
If we reach if we reach this point,
compile directive
something
is wrong.
is very wrong because compile directive should have blown up first.
Exactly. Okay, but now I have a question. So, is this it for signatures overall? No. Wait. Which case is this one? I already lost count where we are. Oh no, this is
This is
nested signatures. We still have to deal with modules.
this is nested signatures. We still have to deal with modules, yes.
Yeah, but definitely not today. I'm gonna finish the recording.